Hi, I'm Jennifer and I'll be talking about pigeons. Let's say that you have a lovely pigeon home with 8 lofts and you have 9 pigeons that you want to house. No matter how we arrange the pigeons, there must be at least one loft that has more than one pigeon. They can be friends. This idea is an example of the Pigeonhole Principle. It states that if I items are put into C containers with I greater than C, then at least one container must contain more than one item. Simple, right? What are some applications of this? One has to do with birthdays. In a room with 367 people, I claim that there must exist 2 people that share the same birthday. This is because there are at most 366 days to choose from, accounting for a leap year, and so by Pigeonhole Principle, at least one day is the birth date for 2 people. Another super cool result of the Pigeonhole Principle has to do with lossless compression. What is that? It's a type of algorithm that makes it possible to reconstruct the original file from compressed data so that no data is lost. I claim that using the Pigeonhole Principle, we can prove that lossless data compression doesn't always work. In other words, there exists a file that is made bigger by it. To start off, assume for the sake of contradiction that lossless data compression algorithms never make a file bigger than it originally was, because that would be counterintuitive. If A is the minimum file size that compresses to something smaller, let A compress to B. Notice how all files of size B cannot be compressed further because A is the smallest file size that can be compressed. Let files be represented using bits. Note that there are 2 to the B possible files of size B because each bit can be either 0 or 1. Now let's look at the set of files that compresses the size B, and also the set of files size B. The left set is composed of all files of size B and 1 file of size A. The right set is all files of size B. This means that 2 to the B plus 1 files map to a set of size 2 to the B. If these elements are containers and these elements are objects, we see by Pigeonhole Principle that there exists at least 2 objects in the same container. In other words, 2 files compressed to the same output. However, this is a contradiction. If this is the case, it's impossible to reconstruct the original image because there are 2 different possibilities, and which one is the right one? Therefore, the assumption is false. For any lossless data compression algorithm, there exists a file made bigger by it. What we just showed is how a basic counting principle can have powerful applications, and this extends beyond just pigeons. Thank you for listening.